Hello dosers, welcome back to another video. We're back, we're finally back after 4 months, and I know you're glad to see me. I'm glad to be back. Let's get right into today's video. So we left off on the first principle. We talked about the first principle in the last video, and this time we're doing the first principle of a trigonometric function in specifically the trigonometric function. We're going to be focusing on that today. So before we do the first principle of a trigonometric function, I want you guys to remember the first principle itself. So do you guys remember it? So pause the video, try to remember it. If you don't, then it's f prime of x is equal to lim h approaches 0 of f of x plus h minus f of x over h. This is the first principle that was taught before. Yes? This is our first principle that we base everything off of. So this means that the derivative of any function of our f of x is equal to this, and this is the first principle. Okay? If you don't understand this, please do go ahead and watch the previous video. That would help in understanding this better. So now that you've understood this, we can move on to looking at our equation, the equation that we're going to be doing for the trigonometric function. So f of x is equal to sine x, right? This is a trigonometric function, and we are trying to find f prime of x, the first derivative. So we don't know what that is. We're trying to find out what that is. So before we apply the first principle to this trigonometric function so that we get the derivative, we have to remember a couple of key limits. So these are the two key limits that you have to remember. Whenever doing the first principle of any trigonometric function, you have to remember as limit of x approaches 0, sine x over x is equal to 1. So this is one limit that you have to remember. The second limit you have to remember is lim x approaches 0, cos of x minus 1 over x is equal to 0. These are the two limits you have to remember. Take a moment and note these two down because they are really important whenever doing any trigonometric differentiation using the first principle. So now let's get into trying to solve this equation. So we try to remember our first principle, right? So we got this lim as h approaches 0, f of x plus h. So we put in lim h approaches 0, right? Sine x plus h minus sine x over h, right? This is after we've plugged in our first principle here. So we have our initial equation. Now, as we look over here, we know that this is a double angle identity. That means that we can replace sine x plus h with sine x cos h plus cos x times sine h. That is this expanded is equal to this. We know that this is equal to that, so we can plug it into our equation. So let's go on to the next page. So now we get lim h approaches 0. Sorry, I keep on saying lim. It's just limit h approaches 0 of sine x. Actually, let me do this in a different color. So sine x, and then we switch back to red, cos h plus cos x plus sine h minus sine x over, this should be in a different color, sorry, minus sine x, yeah, over h. This is it. So the reason I've done these two in different colors over here is because we're trying to group these two together and separate the limits. That's what we're trying to do here. So we group these two together. Once we group these two together, we can pull out the sine x. So if we try to separate our limits and we separate them in general, so if we do lim h of 0 of sine x plus sine x times cos h minus sine x, we can write it in the form sine x times by cos h minus 1 is equal to both of those combined. So that over h, and then we separate the limit by adding a plus and then the rest of our function here. So lim of h approaches 0, right? Sine h cos x over h. We've done nothing different. We've only pulled this out from this and this. We've grouped these two together, this brother and this brother. We've grouped these two together and we've pulled out the sine x, and then we put a plus sign in the middle. This is the same as this. We've just grouped them two together. Okay? Once we found this out, what we can do now is that we can pull out the sine x and we can pull out the cos x, because these two we can pull out because they have nothing to do with the h is equal to 0. The limit only applies for h. So any variable that has a h, we cannot pull out of the limit. We can pull out x because it has nothing to do with the h. If you pull out the sine x, you're going to get the same value if you plug in h is equal to 0. And if you have the sine x in this limit, you're still going to get the same value if h is there. Okay? So we pull out the sine x of limit h approaches 0 of cos h minus 1 over h, and we do the same thing for cos of x because the variable x is now with cosine. So we do plus cosine x of limit h approaches 0, yes, sine h over h. So now we have these two to deal with. Now I'm just going to add another page and we're going to work on it. So now we have two things. So we have sine x limit h approaches 0 cos h minus 1 over h, yes, plus cos x limit h approaches 0. Let me just look at that again. Sine h over h. So sine h over h. Now I want you to look at these two very, very carefully. These two right here. And look at the limit too. Okay, limit of h approaches 0 of cos of h minus 1 over h, and limit h approaches 0 of sine h over h. It looks awfully familiar, does it not? Well, that's because these are the key limits we looked at the start. So what do we see here? Sine x, as limit x approaches 0, sine x over x is equal to 1. So that means limit h approaches 0 of sine h over h is also just 1, right? So we do cos x times 1. That's our limit. This limit goes into 1. Yeah? And that added with cos h minus 1, the limit of x approaches 0 of cos x minus 1 over x is equal to 0. So we essentially assume this as 0. So sine x times by 0. This limit goes to 0 and this limit goes to 1 because of our key limits. These are defined and these have been calculated, and these are stagnant values. They're never going to change. If you find this limit in any sort of equation, just know that this equals to 1 and this equals to 0. Okay? So after that, sine x times 0 is equal to 0, and cos x times 1 is equal to 1, is equal to cos x. So that ends up with cos x. That is solved. That's your trigonometric equation done. Your first derivative of sine x is cos x, so we know that our derivative is correct, and we've applied the first principle correctly. Now, I have unfortunately added some homework for you guys, but it's not too hard. It's just the opposite way around. I want you guys to find the first derivative of f of x, but this time f of x is cos x, not sine x. So please do try this out. The mark scheme is given on the next page. I hope you have enjoyed today's video. If you have, please like, share, subscribe. Send this to anyone who needs some help in maths AHL. I know it can be very, very difficult. I have a lot of students that are really struggling with this. So let me know in the comments below if there's anything you want me to include and anything I've missed out on. Thank you so much for watching today's video. Take care and have a good one. This is SK signing off.